No. All right. So we're group A, and we're going to be showing the spec spectroscopy data that we found, and using the data which copper site we determined was the best fit. So I'm going to be going over the first response post question, which is to show the total volume delivered and concentration for each solution in the graph. So I'm going to be sharing my screen. And here is our Excel spreadsheet that we made. So first, here's my concentration numbers that we found. So, and then here's the volume delivered that we found. And we determined these numbers using the dilution formula and the volume delivered formula. So here I'm going to be showing an example of how we used it. So for the first one that we did, we used the dilution formula M1V1 equals M2V2. So here I plugged in for the M1 is 63.55 milligrams per milliliter, which is a stock solution that we were given. Then for V1, we use the 50.00 milliliters, which is the volumetric flask that we used. And then that's equal to M2. M2 is M2 because that's what we're trying to solve for. And then 1.01 milliliters is actually the volume delivered that we found. So the way we determine the volume delivered is we use the 1.26 milliliters, which is in the first, these two numbers are in the first set of numbers that we were given. So 1.26 milliliters minus 0.25 milliliters, that gives us 1.01 milliliters. So that's what we plugged in for V2. And once all these numbers are plugged in, for M2, we get 1.28 milligrams per milliliter. So that's the example of the math that we did. And I'm going to pass it on to my partner.
Right, I will be continuing and talking about the construction of the Beer's law plot and the relevance of using spectral data to analyze the two possible copper mining sites. I'm going to be sharing my Excel. All right, so we have the graph right here, the Beer's law plot title to the right, and the graph consists of the two number coming from the absorbance was given, and the concentration which is calculated from part 1. So the absorbance is representing the y-axis, while the concentration represent the x-axis. Also, we have add a trend line and the equation of that trend line in the graph to be able to tell. Right. And next up, we're gonna talk about the why spectroscopy a proper technique for this analysis of copper to sulfate pentahydrate. So I think from the Beer's law plot that we found, we can tell the proportional between the concentration versus the absorbance. They will produce a linear relationship with the positive slope. So you can tell and determine the concentration of the solution and the absorbance of the solution by the measure of its concentration using the linear relationship from the graph, or vice versa. You can find the concentration using the absorbance. Also, you can tell the more concentrated the solution, the more absorbance, since the light cannot pass through the highly concentrated solution. That should be part 2 of this. We're gonna walk through part 3, which is gonna be describe how it will use to determine the concentration for the two possible copper mining sites. So as I said earlier, the absorbance is gonna represent the y-axis, and the x-axis is gonna be the concentration. We was given with the test sample from site 8 and site B, which is the 0.149 for site 8 and 0.260 for site B. From that number, we're gonna plug in the absorbance, which is the y. So we plugged in, and then we're gonna find the x, which is the concentration, and we found those two number the two concentration from site A and B, which is 0.818 for A and 1.39 for B. I'm gonna pass on to Jose to finish.
Okay, so now that we explained what numbers we got for site A and site B, the concentration, we determined that the best fit would be, or the best site that we picked would be site B, because the concentration was bigger in site B, which means that it has a higher like concentrate of copper. So for example, if you were to use the light test that we used in the lab that we did, then if you tried to pass light through it, it wouldn't pass through as much as it would on site A. So if it doesn't pass through well on site B because it has a higher concentration, that means it has a higher absorbance. So that determines that it's higher concentrated, which has more copper substance in it. Therefore, you would want, the best economical choice would be to pick site B to mine that for copper.